Welcome back. We are continuing our study of software-defined networking applications in the wild, and in this lesson we will look at applications of software-defined networking in home networks. Users of home networks face two challenges. One is achieving the appropriate level of visibility into usage and problems that may arise in the home network. Answering even simple questions, such as where the source of a problem is, or which device is hogging all of the bandwidth in a home network, are particularly vexing and difficult today. A second problem is providing users with control to help them better manage resources, usage caps that may exist or be imposed by their internet service provider, and so forth. Unfortunately, home network configuration can be extremely complex and low-level. While your home network may not look quite this complex, many of us have certainly experienced the frustration of not being able to diagnose problems that arise in our networks at home. Too much of this complexity is exposed to the user. We've experienced some of this frustration in the configuration modules that exist in today's home routers. Unfortunately, current means for managing home networks provide neither visibility nor control to the users of these networks. Users have a very difficult time figuring out the answers to simple questions, such as how much data they have left on a usage quota and when they'll run out. The process by which applications consume both bandwidth and usage are also mysterious and difficult for users to understand or control. And finally, in homes with multiple users, it can be particularly difficult to understand which applications in the home or which devices are responsible for usage that may interfere with the performance of other applications or exhaust usage quotas. One solution to these network management problems is to apply software-defined networking to centralize and outsource the control of a home network. In our lab at Georgia Tech, we have implemented such an SDN control system for home networks, whereby an SDN controller sits outside the home network and monitors various behaviors and events that occur inside the home and send commands to manipulate flow table entries on the wireless router inside the home. On top of that SDN controller, we can build more sophisticated features such as graphical user interfaces that make the network easier to manage and easier for the average user to understand. The controller that we have deployed is based on the resonance controller that we discussed in the last module. In the case of managing usage caps, we have configured that controller to maintain multiple states for each device inside the home, depending on how much traffic a particular device has used over a particular time window. If a device exceeds its usage quota for a particular time window, we can then use the controller to shift that device's state from a normal state to a capped state, whereby the device is either blocked outright or its ability to use the network is more limited. Let's now look in a little more detail at two specific applications of SDN control in home networks. The first is the home network management application that we just talked about briefly. Moving the SDN controller out of the home allows for more flexible control and management models for a home network, potentially even creating the possibility for third parties to manage the network. Moving this control off the home router also makes it possible to develop remote control and better user interfaces for home network management. A second application is what is called slicing of the home network. That is, virtualizing the network infrastructure to allow service providers direct access to the home network infrastructure for tasks such as video streaming, smart grid applications, and so forth. Let's now take a look at the first application in a little bit more detail. A key problem in home network management is usage control. Many internet service providers have begun to impose usage caps on their users to limit or control the amount of data that a particular user uses over the course of a billing cycle. Unfortunately, users may have a very difficult time understanding how different devices inside the home consume that usage cap, and an even harder time controlling the devices that may be hogging all of the usage quota. To mitigate this problem, we have developed a system called UCAP, which allows users to see how different devices in the home are contributing to their overall monthly network usage. Equally importantly, the user can use the interface to control and limit how different network devices consume that usage cap. Perhaps the most interesting part of this system is that all of the machinery under the hood is implemented with the Resonance SDN controller. Here's an example of the UCAP interface in action for a real home network. On the left, you can see a list of devices, some of which have been labeled, as well as a bunch of other devices that the user has not bothered to label. The pie chart in the middle shows a breakdown of network usage for this particular month by devices. The History tab shows which devices consume the most data over the course of a particular time interval, as well as the top domains for this home by traffic volume. In addition to providing the user better visibility, UCAP also provides the user better control over how devices consume data over the course of a month. The Manager tab shows all of the devices and allows a user to set a usage cap for a particular month. When a user sets a usage cap, the controller then listens for an event that indicates that that particular device has exceeded the usage cap for that particular month. When the controller receives that event, it shifts the state of that device from normal to block. Another application for the billing cycle SDN in the home is slicing. Consider a situation where different service providers, such as a smart grid provider and a video streaming provider, each want access to different resources or infrastructure in the home network. Many of these service providers want to offer services to home users with guaranteed performance and reliability. Unfortunately, it is very costly to have each of them deploy their own network infrastructure. A solution to this problem is to slice the home network such that each provider controls a different slice of the infrastructure or resources, using the flow space concept that we saw earlier in the course when we looked at FlowVisor. In summary, home networks can be very difficult to manage because users have very limited visibility and control over what is going on in the home. Service providers who may want to offer value-added services also have limited access. We've looked at two applications of SDN in home networks: usage cap management and slicing of the home network, each of which illustrate how the use of SDN to refactor control in the home network can make home network management much easier, both for the users and for service providers.